Hi! Time for some more experiments with magnetic levitation on an induction cooker. Can the setup from my earlier video be improved by simple means? Perhaps even stabilized without tethers? Is copper better than aluminum? I will test some of your suggestions. Some will give crazy results, others crazy good. Playing with induction cookers in ways not intended can start fires near high voltage. And also be aware of stray high wattage electromagnetic fields. First of all, thanks for all your inspiring suggestions on the earlier video. More than I can test in this video, but keep them coming. For an easy start, I would like to improve on the already working ring. Adding more mass might lower the levitation and keep the cooker on for longer. The original ring is 2-ply. How about 4 times more mass in an 8-ply? Oh, the cooker refuses to turn on. Too much non-ferromagnetic aluminum to fool the cooker. Same for 6-ply and 4-ply. 3-ply is the maximum for this ring size on this particular cooker. Flimsy, lightweight 1-ply is great for high jumps, but comparing their end heights after the initial jump, they are surprisingly similar in levitation height. Maybe adding more weight by making the ring taller is better. Not much improvements in terms of stability, but the 1 cm lowrider ring is a high jump champ. Almost an electromagnetic ring launcher. That's just not the goal here. Maybe the geometry needs refinement. Some of you mentioned Möbius. Ooh, I like the one-sided weirdness of the Möbius strip. Let's try it. Well, I think the problem is it is not sitting flat enough on the cooker. Flatter might be better. No. Don't go melting on me. I need the cooker for further experimentation. Whoops, the cooling fan tried to eat it. But the flat ring is now down to a promising size. Yeah, that's a thing. Not sure what to call it. A flying saucer's first baby steps? Cute, but feeble. More plies should sturdy it up. Will 4-ply work for a flat ring? Yes, lower initial jump than the upright rings, likely due to more aerodynamic drag on the flat surface, making it less prone to escape. Great, but it is clear that more electrically active aluminum mass does not prevent the cooker from turning off. I tried holding it down with some inactive paperboard, but the cooker still turns off. How about way lower levitation by a way higher inactive to active weight ratio? Like a CD. Okay, too little active aluminum here. Let's give it a kickstart. Oops, it melted the CD. An effective reminder of how hot the ring quickly gets. Combustible, inactive weights and tethers are not really a safe option. Another suggestion is more weight by using a more dense conductor. Copper could work. It is a better conductor, but far more dense. The only copper foil I have is copper tape. It is beautiful, but hideous to work with. First, I will try with the stabilizing plastic film left on. Nope, not fooling the cooker. Copper might be a great solution if I can find the delicate balance. Aluminum is just much easier and cheaper to use. Moving on. Ooh, I wished I had a thin-walled hollow toroid made of aluminum. I tried adding rings to the ring, but this monstrosity is not a full toroid and the cooker does not appreciate my effort. Now I can't help but think the heating of the levitating aluminum causes problems in this sensitive setup. Higher temperature in a metal affects factors such as its resistance, impedance and inductance. What if I use an airstream to cool and push down on the levitating ring? Except some wobbly rotation, I don't see any major difference. Ah well, was worth a shot. After a short message, I will test a tip that actually gives me what I wanted, but makes me question if I want what I want. A big thanks to all my patrons. I appreciate your help with keeping these videos like this one coming. For just $1 a month, you can help me out too and get full access to all my posts on patreon.com. Link in the description. Thank you. Water cooling is far superior to air cooling, so this comment caught my eye. A water-filled can absorb a lot of heat. 100 grams of water should be enough to pin down the can. Yep, just need a larger diameter can. Or 2 cans with 100 milliliters of water in each. As you probably can tell from my hesitating hand, I did not expect this result. The ring kinda stabilized and the two 100 grams cans move apart. Stronger forces involved than I thought. Alright, filling up to 250 and 300 milliliters totals. Wow, a lot of things to notice here. First of all, the cooker stays on and keeps the ring levitated until turned off. Surprising, since the 2 cans alone is not enough to turn the cooker on, and the ring alone will quickly turn the cooker off. But combined, they keep the cooker on at 2000 watts, heating up the water. The ring unfortunately collapses against the cans, presumably due to magnetic attraction. I then tried with 3 smaller water-filled cans. This arrangement is finicky, and once levitating, the ring quickly gets worryingly hot. And the 1/4 kilogram cans still move apart. More mass, please. Okay, the water in the cans is doing its job of keeping the ring and cans from melting. My main goal was to get a stable hovering ring. I sort of have it now thanks to this great tip for magnetic anomalism. Thank you. However, it's suddenly obvious to me that a static display is not interesting for long. Like the diamagnetic levitation. Absolutely fascinating to experience. But it only takes some seconds before I start poking it. A dynamic display grabs our attention much better. I mean, which one are you looking at right now? One more tip to try. Lower the power of the cooker instead of max jet power all the time. The display says the cooker is delivering power, but it isn't always. It seems to run at lower power settings like a microwave oven, by turning on and off at intervals. That's useless for Levitation. Time to upgrade to a modern, sleeker version. If I read this graph right, this induction cooker can regulate its power without fully turning off. It sure looks better and more expensive than the old, more plasticky one. Reminds me of a DJ controller. Anyway, will this stay on at lower power settings? Ah yes, the pulsing at 120 watts is so noticeable and fun to watch. I am pleased with this dynamic display of electromagnetic levitation on an induction cooker. The ring is on the move, yet hovering most of the time, and gets a chance to cool a little on the glass at intervals. Perfect. Once again, thanks for all the great ideas. If you liked the video, click like before the haters take over. And subscribe to not miss out on my next oddball video. Meanwhile, I recommend watching the video where I launch springs using a strange permanent electromagnet hybrid. In any case, thanks for watching. Bye for now.